What we're looking at in this video is network security, and we're taking a look at some of the protections we can put in place to stop some of the hacking or cracking attacks. And so one of the first things which can be done to protect a system is permissions. And so we're dealing here with user access levels, so the level of access that a user has, and in particular we're dealing with folder or directory permissions and file permissions. So here's an example of the Windows system. This is Windows 7 with the way in which it uses permissions. And the key permissions which you need to look at and think about are the execute permission, which means you can run a program. Obviously you need to be able to read the file in order to run that program. And then you've got the read and the write permissions. The other permissions aren't so important to really understand. And so what you can set in the case of this spreadsheet here, so I'm looking at a spreadsheet, the groups here and the users here are allowed to do all of these things, and at the moment it's saying the system user can do all of these things. And you can set up the different users or different groups of users can have permissions to do these things or to not do them. And so that's the way that Windows deals with it. Unix permissions, which is how you often see things done on the web, so a lot of web servers will use Unix or Linux or something like that. And what those permissions will look like is just a series of numbers. So down here we've got the permissions down here for each of the files here. And what those permissions translate to is given somewhere like this. So this 644 means that everyone so this user, so anyone who's a user, and the groups of users and the world, which means anonymous people, they can all read these files. In the case of writing though, I've got to be a user, the user that created this file, in order to actually write to it. And no one, whether it's me the user, a group of users, or general people in the world, nobody is allowed to execute this file. And so this prevents people, let's say that this file was a virus and I was trying to get someone to run it, the file permission will prevent that file from being executed because it doesn't have permission for execution. So it's a way of preventing people from running programs that aren't allowed. We say that file doesn't have the permission to be executed. And so that's how it's dealt with in Unix. Very, very similar systems now between Windows and Unix. In terms of another way to protect a system, what we use is encryption. And this is a key security method. So let's say we have a computer down here and I'm trying to talk to my bank over here. Then I send a signal across to that bank. If that's my password, and let's use a terrible password like hello, if I send that through HTTP, then it will go through the network just saying hello. And it's possible to use a thing called a packet sniffer. And what a packet sniffer does is it has a little look inside as things are leaving through the network, and it lets you see the plain text of what's going through. So if ever you're using a website just with HTTP, literally anybody on that line, and remember it's going through lots of computers to get there, anybody can have a look at what you're sending through, and if that's a password, they've got your password. If it's documents, they can read those documents as well. So encryption is a way in which we scramble the contents of a file or a communication. So it's scrambling information. And so what encryption might look like is I might have the string hello, and then that gets scrambled or encrypted into something that looks more like that. So there is no way that hopefully that somebody can translate this into this. And the way this is done with respect to passwords, for example, so let's say that your password, I'm storing a username, so I might have H Smith. Now I could store his name in plain text as the password. And so when he logs in, I just compare, is his password hello? This is really a poor way of being secure though, because if somebody gets hold of that password list, they have every username and every password. So to add to our protection, instead of putting in the actual password, what we do is we encrypt the password with one-way encryption, and we'll make it the encrypted password that gets stored for this user. Now, decent websites, decent programs will not be able to tell you what your password is. When they say, if you phone up the bank, we can't tell you what your password is, it's not just we don't want to tell you, it's often they actually can't tell you what the password is. There is no way of doing it. This is a one-way encryption, so it's very easy for the program, the algorithm that does this. It will be very easy to translate this plain text into the encrypted version. But the opposite will be very, very, very difficult to do. In fact, incredibly difficult, and it will take possibly tens of years of hundreds of computers working on it to try and crack this password. So that's how passwords get encrypted. And the idea in terms of picking your password, so hello is a particularly useless password. So what will happen is you have a thing called, well, there's two attacks you can do. One is a dictionary attack, where you take common words from the dictionary, so it literally just goes through trying every word in the dictionary to see if that is your password. And that's one way of attacking. The other one is called a brute force attack. And what a brute force attack does is it will try A first, then B, then C, and then it will try A, and then A, B, and then A, C, and so on, until it's gone through every possible combination. So brute force attacks take a lot of time unless you use very simple passwords. So if it's short, if it's all lowercase letters, a brute force attack has a chance of working. And if it uses dictionary words, a dictionary attack has a very good chance of working and breaking those passwords. So that's why now everywhere you see will say try and pick a password that contains lowercase and uppercase letters and numbers and possibly other symbols as well, because this is very, very difficult for a dictionary or a brute force attack to have a go at cracking this password. So another type of protection which we can implement, which again is to do with encryption. What we can do with encryption is we can encrypt connections. So instead of using HTTP, which is just plain text and anyone can read what we're doing, we use HTTPS. So this is the secure version of HTTP, and this encrypts the data between us and the server that we're talking to. We can also encrypt documents. So before we send an email, we can encrypt the document and then attach that document to our email, and then the person at the other end can decrypt it so that no one in between can see what we've written. And we can also encrypt our emails themselves, and even hard disks or storage devices can be encrypted so that every single bit of data on them is encrypted. And this is important because if you delete the files or you format your hard disk before you sell the computer or get rid of it, the data is still on it. It just says all this space is available to be used. So by encrypting the work on the hard disk, even if that hard disk is stolen or when we sell it, the information is encrypted. It's much, much harder for somebody to get hold of what that information says. And so there we've covered 3 different ways in which you can increase the network security and the security of your systems, which is to have permissions on your files and folders and directories, to have encryption, and to use suitable passwords. And those are some of the key ways in which we increase our network security.